Yeah, today we are going to solve leetcode problem 2770. This is the problem of the day, and the problem is the maximum number of jumps to reach the last index. So we have to find this problem. We have to find the maximum number of jumps which we could take from this given array. Initially, which is starting. Initially, we are present at index zero. After that, we have to jump to index uh, I to j, which will satisfy this following condition, which is mentioned here. So yeah, you can clearly see that this is a problem related to this because the problem which are related to maximization, minimization is something we can say they are very correlated to TP. Because if we are first of all, let me clarify this problem in more detail. So initially, what is given that in the problem is that we have given an array whose name is nums and whose size is n. After that, we have given one more integer value, which is named as target. And what is mentioned in this problem is that initially we are at index 0. And each step, what we have to do is, suppose we are at general index I, we have to we can jump to index j if and only if this satisfies the following conditions. The conditions are if j is greater than j needs to be greater than I, and second condition is that the difference between the values present at these indexes need to be less than or equal to the target value, means absolute value of target value. Absolute value of the difference need to be less than or equal to target. Okay. So we have to find the maximum number of jumps which we could take to reach the f index minus one. And suppose if the condition arises that we are not able to reach at index n minus one, means at last index of the array, in that case, we have to return minus one. Okay. So let's see one example to get more clarifications about to get more clear about the problem. So here we can say that our output is two, means what it is means that we can uh, jump max to max three jump to reach at the index and minus one at the last index. So initially we were at index zero, so we have to reach at index minus one. So what we have taken is we have first jump from index 0 to index 1 because the difference between 3 and 1 is 2, which is less than or equal to the target value. After that, after 3, the difference between 3 and 6 will be greater than 2. So we can't jump from 3 to 6. So in that case, we will proceed to 4. And we can see that the difference between 3 and 4 is 1. So which is less than or equal to target. In that case, we can jump from index 1 to index 2. So till now we have done two jumps. After 4, we can't jump to 1 because the difference between these two values is greater or equal to target. And so in that case, we will jump from to value 4 to 2, which means from index 3 to index 5. So this is the most optimized jump, or we can say most optimized answer for this particular example, because if there is no other sequence of jump is present, which can give more output than 3. So this is the 3. So this is the answer in this problem. Similarly, we can see for this also. So how we will came to know that this is a DP problem? Because if we see at each step, or we can say at each position, we have number of possibilities. That like that we can jump on 3, we can jump on 6, we can jump on 4, we can jump on 1, we can jump on 2. So then if faces problems like a problem where we have number of possibilities where we can go from a particular point, and we have to optimize that path. Means we have to, as we have number of options, from one we can jump to the number of options, number of other indexes present in front of index 0. But given that these following conditions are also satisfied, we can see that if we are at index 0, so we can jump on 3 as well, we can jump on 1 as well, we can jump on 2 as well. So there are three indexes which are present in the front of index 0 on which we can jump, which are satisfying these following conditions. So we have to select the most optimized jump. Means we have to select from these three possible indexes. We have to choose that particular index which give us the maximum value, or we can say the most optimized value. So where the problem of optimizations come. These are the problems of optimization where we have to maximize or minimize. So in that case, we first we need to think the DP the DPs should need to become in our mind because DP is used to solve this kind of problems only. So till now we came to know that this is a DP problem. So as you know that I always mention in my solutions that before solving any DP problem, we first need to know the states. What are the whether is a 1D, whether is 2D DP or whether it's 3D DP, and what this DP state means. So let's see this example one more time. As we are moving from index 1 to suppose as index 2. So what are the how we will decide the what is the number of states? So here we can say that if we move from index 0 to index 1, in that case, what are the number of variables which are changed? First, it is it is clear that the index value will change. So it is a 1 which is perfect. And we can't see that any other states are changing. So we can see that we can see that in the 1D DP. So, and what is a particular, suppose DP of IDX? You have taken IDX as a variable which is representing the current value of index at which we are present in our num array. Okay. In that case, what a particular DP state means. Suppose our DP state. So till now we have seen that what is the DP state of this particular problem. So the second thing is that now we came to know that this problem is related to 1D DP. So now let's solve this problem. So what we will do, first we will find the length of our nums array, which is nums dot size. After that, what we need a DP. So I will declare my DP in the global variable. So first of all, I will size this DP, whose size will be nums plus one. And one more thing is that what is the initial value one which we need to be initialize our DP. So generally, what we do is that we always initialize our DP value with a minus one. But in this case, our minus one can be as minus one can be as one of our outputs. So in that case, we can't initialize our DP value with minus one. In that case, we need to take a value which is not possible in our answer. So suppose so in that case I will take a large negative value. So I will initialize a ESP, which is a very large negative value. Suppose that is it will be 10 to the power minus 9, and I will declare one as a DP as I have mentioned, and the DP in my global variable as a global DP. So uh, so if the initial value of the DP will be ESP, the variable which I have declared above. So I have to return. I will make a one more function which will return the maximum of this jump. And initially we are present as the index 0, so this is the first variable, and second parameter which we will pass will be the number of length of our nums, and the third parameter will be the target value, and fourth parameter will be the nums, which is our array which we are passing. Okay, and after that, we will define our function. So max jump. So the IDX will be there, even time will be there. Okay, and after that in the target value which we are passing, and after that vector in and nums we will pass. Okay, so what will be our base case? Our base case will be in the case when we get into that when we so our base case will be in the case when we reach at the last index, that will be our base case. As I have mentioned, our particular state represent what as I have mentioned that a particular state. What is the DP of IDX? DP of IDX means DP of IDX means DP of IDX means the maximum number of jump which we could take from reaching to index and a minus one from index IDX. And as in base case, we already reached on index minus one. In that case, we will return zero. Okay. And suppose if we have already calculated the DP of IDX, that particular index, which is not equal to SP, in that case, we will return the DP of IDX. Okay. Now, we will make a global variable as we have number of possibilities. So we will take the optimized value from all these branches which we will get uh, from a particular index by index IDX. So we will maintain one global variable. So to get the answers from all the possible branches or means all the possibilities from, from a given particular index IDX, we will make a loop. So int loop will be the start from index plus one, idx plus one, and it will go up to the last index, and its value will be jj plus plus. After that, we will find the we will store the result of the particular branches in a variable which I have declared as a result res, and which we will get from by calling the function one more time and initializing int and target. After that, none. So there can be two possibilities for the result which we are storing here. First possibility is that the result value is just plus minus one. Means there is no possible way to reach from index j to add to the last index. In that case, we will do nothing. In that case, our value will be the equal to minus one. It remains the same. So in that case, if it is value is not equal to minus one, means we are getting some results. We are getting some possible answer. So in that case, we will compare our answer with our value. It is a we will take the max of val and result plus one. So after getting all the answers from the possible branches, or we can say possible paths, we will store our value in our IDX, and we will return that particular value. So I think this will be the whole problem which we have solved. I think the solution will be clear to you all. Let me run this problem. I will run this too. Okay, what is the problem? Oh, one mistake I done. I have kept here and minus one instead of QVBS. So I think now we'll run for all the cases. Oh, I forgot to mention the condition. Okay, sorry for my time. I forgot to add this particular conditions. Sorry. So if absolute of nums of j minus nums of I will be less or equals to target value. In that case, only we will do this following things. Okay, I forgot to add that particular conditions. Okay. So in this case, the result is equal to first of all. Now that one this. Okay. So okay, I know. Sorry. As we can see that it is running for the following game. Okay. Now let's submit this problem. As we can see that it is accepted. So this is the basic problem of this. This is the basic DT problem for this particular given solution.